Today I'm talking about agriculture and research and science and technology in that. So talking about some soil acidity as well as some new technologies coming through, from new chemicals to lasers for weeds. So I'm Ashleigh Lydon. I work as a development officer in livestock at the Department of Primary Industries and Regional Development in Merredin. STEM skills are really important in the agricultural industry, just for future development. Lots of new technology coming through, drones, specific spraying, machine learning, as well as new chemicals and lots of new scientific discoveries and innovation in agriculture as a whole. I see technology continuing to have a big influence in the industry. It's already had a huge influence with new machinery and new chemicals, new genetics coming through. I think that's just going to continue with autonomous vehicles as well as robots, and just increasing our profitability and our options in the ag sector. I'm still very early in my career. I'm still learning a lot, but I'm really excited to see how the ag industry will continue to develop and the different innovations that will come through. Behind a lot of that, all of those crops and sheep, is a lot of innovation, technology and science. So as a scientist, we have a lot of things we need to consider. We have the climate. What's our rainfall and temperature looking like? How does it look currently? And how is it going to look in the future? How is it changing? We have the soils. What microorganisms do we have? What soil-borne diseases do we have? What constraints do we have? Do we have an issue with pH, salt, or just the structure of the soil? And then we have the crop itself. What nutrients does this crop need to grow? What insect, weed and disease issues do we have? What challenges do we have? And then we have sheep. Do we even have sheep or livestock in our system? Are they for meat or wool, or are they both? And then how do they fit in with our cropping enterprise as well? And then we need to consider the farmer himself or herself. What are their goals, values and drivers? What's most important to them? And I guess most importantly, what's economically and actually physically possible to implement on farm? So an example of one of the challenges that many farmers experience is soil acidity. And so this is when the pH is too low and out of that ideal pH range for plant growth. And so as the soil becomes more acidic, essential nutrients are harder for the plant to get a hold of. We already have a solution for this. So this is sand from Lanceland. It's called lime sand. So this is sand that is very high in calcium carbonate. So it's a good base to neutralize soil acidity. And so what we do is we take it and we spread it across the top of the soil, or we incorporate it into the soil, and then with the water it spreads out. One of the problems we have out here is that it's 350 kilometers to the nearest lime sand pit. So not only do farmers need to purchase the lime sand, they also need to truck it 350 k's. So what has been found is this picture on the right is these on-farm lime pits. So this is a specific soil type that's quite alkaline, and it's got these calcium carbonate nodules in it, so all the white stuff. But we have a problem that these are quite variable. Some aren't very good quality, and we need to be selective with which ones we send off to go get tested. So we have a way to test that. So here I've got two soils. One is a soil with calcium carbonate, and the other is just some random soil I found at the research station. So what we do is we use either hydrochloric acid or vinegar, which is what I've got in these other beakers. So if you guys just want to pour some of the vinegar into number one. So literally nothing happened in these ones because the soil doesn't have any calcium carbonate. Do you guys want to pour some in number two? Yep. And so this one should fizz and bubble up. What we would then do is we would take this soil that's fizzing and we would send it off to get further tested, just to make sure that it's a good source that is actually going to be economical to use on farm. Some of the other technologies that have been investigated include XRF, which is using X-ray, as well as infrared technologies. And these are used in the mining industries. The problem with these ones is that they're very expensive. Plus, you need to do a lot of preparation of your sample. It's not just a point and shoot. and you need a license to actually operate them because they are using X-ray. But what they did find is that using the fizz test, using hydrochloric acid and preparing a sample in a specific way, that could actually give an indication on how effective and your neutralising value of your soil. And it's a lot more practical for farmers to use. And then from that, they'll send off their soil to go get tested still. So some other work I've been involved in is using satellite imagery to give an estimate of livestock feed on offer. So how much food we have in the paddock to feed our livestock, so we can plan where we're going to put our livestock when. So this is called pastures from space. That the satellite uses NDVI, which is an estimation of plant photosynthesis, and then we relate that to biomass, and that's how we get our food on offer, which is the kilograms of dry matter per hectare. Instead of having to go out and check every single paddock, we can log on and get an idea of what our paddocks are looking like and plan where we're going to put our sheep with our feed budgeting. We've been improving our practices since forever by using farmer experience as well as backing it with research. So an example of this is in the 1990s, there was a big move to reducing the tillage, so less turning over the soil. So this meant that we're not drying out the soil as much, so we have more moisture, and we're keeping the stubble so that the soil isn't going to blow away if we get a big wind event. So we don't want weeds in our crop because they take away nutrients, water and space. One of the big issues we have is because we often use chemicals to control weeds. If we use the one chemical over and over, the plant becomes resistant. And so we have to either keep putting more and more chemical on, or it just stops working altogether. So we've had new technology in the form of new chemicals come through, which has been really good, as well as mechanical technologies, such as the weed seed destructor, which farmers are using. We also use strategies like we rotate our chemicals, so we're using different types of chemicals. In terms of, I guess, some more innovative or like newer forms of technology that have been coming through that aren't on farm yet, we have lasers. So this is a robot that it takes photos and like notices all of the weeds, and then it zaps them with a laser.
Wow, that's cool.
So the flashing's the camera. And we've got heaps of other different developments in the industry. We have the weed chipper, which was developed by UWA. And so this uses cameras to identify our weeds, and then these little scoops at the back literally just chip it out of the ground. So we're not having to use chemical at all. And then we have the green on green sprayer. So this uses cameras again to identify weeds, and then it only sprays where the weed is. So we're not spraying the whole crop, we're only spraying the weeds. And then we have things like drones, and we've got the swarm farm and different other technologies coming through. So one of the things that I've loved the most about ag is that it's so diverse and there's so many opportunities, and it's continually growing, and there's always space for a lot of, I guess, creativity. Yeah, it's a really encouraging and growing space. There's lots of new things coming through. So the advice I'd give myself for my future career is just to try everything when I have the opportunity. Take those work experience options and just taste and try a bit of everything to work out what you're interested in. So advice I'd have for students interested in the ag sector would be, like, take the plunge. There's so many people to learn from. Ask lots of questions. You don't have to be from a farming background. I didn't come from a farming background. And lots of people just welcome you and teach you so many good things. So ask lots of questions and just go for it.